Okay, so we're going to look at another one of our number systems to deal with digital electronics, and that is the hexadecimal number system, which is base 16. So just like the octal number system, this is used with binary to allow us to transfer more binary information in less space. So hexadecimal is base 16. If you think about our binary number line again, it goes 1, 2, 4, 8, 16. So it works well with the binary system to transfer that information. All right. So again, if you haven't already, jump on Blackboard, look at the notes for the hexadecimal system to look at how it works and how it's laid out. So I'm not going to get into all those details in this video. Just going to focus on counting and doing conversions to binary with the hexadecimal system. Okay, so first we will look at counting. Alright, so again, to do a side-by-side comparison of hexadecimal with just a regular decimal value. Alright, so this is a base 16, which means we have 16 values per place value. Okay, so the first 9 are just like they are in decimal. It's 0 through 9. Alright, but then things get interesting. Alright, so after that point, we go from numbers to letters. So after 9, we have A, B, C, D, E, and F. So that is 10, 11, 12, 13, 14, and 15. Okay, so that's 16 total values. So it's numbers 0 through 9 and then letters A through F. So after F, that will be our transition point. So F is like our 9 in our decimal system. So after F, that goes to a 0. This becomes a 1. So 10 in hexadecimal is actually worth 16 in decimal. So then it would be 11, 12, 13, 14, 15, and on we could go. Comparing that to decimal would be 17, 18, 19, 20, and 21. Okay, again, don't really stress about the decimal equivalents. So what you have to know here is that with hexadecimal, you have the numbers 0 through 9 and letters A through F. Alright, so again, getting a random hexadecimal number with the subscript 16 there to let me know it's a hexadecimal number, and we're going to just start counting. Alright, so we have 3D8. Alright, so after 8 is obviously 9, so that's 3D9. And then remember, 9 is not going to be our stopping point here. We switch to letters. So then we have 3DA, 3DB, 3DC, 3DD, 3DE, 3DF. Now we are at our transition point. Okay, so F as far as we can go, so that will go back to a 0, and I add 1 to the left. Well, to the left is not a number, it's a letter. So now I got to go to the next letter, which will be E. Right? So now we got 3E0, and then 3E1, 3E2, 3E4, 3E5, 3E6, 3E7, 3E8, 3E9, and then 9 we go to letters. So 3E A, 3 E B, 3 E C, 3 E D, and on we could go. All right, so it makes it a little more challenging because you have the numbers and letters to deal with, but just remember 0 through 9 and then don't stop there. Go letters A through F, then you go back to 0 and start over. Okay, so a little bit more involved in octal, but still a lot easier to count than in binary. All right, so next let's jump into converting. So again, because this number system is used to transfer higher rates of binary data, that's what we're going to focus on, switching from hexadecimal to binary. All right, so the conversion to binary is identical to the conversion to octal. All right, so the only difference here is instead of doing groups of 3 like we did with octal, here you're going to do groups of 4. All right, so that means you need the first 4 place values of the binary number line. So 1, 2, 4, 8, and then you just need as many of those that is required for the number that you're converting. So each place value in hexadecimal is worth a group of 4 in binary. Okay, so the procedure is the same. So my first number here is 7. So 0, 1, 1, 1. Right? 4, 2, and 1 is 7. All right, and then here I just have a 1. So that's just a 1 in the ones place. Then I put all that together, and that is my answer. 0, 0, 0, 1. 0, 1, 1, 1. Okay, and again, you don't have to have these leading zeros, but it's okay to write them. All right, so the next one is 5B. So here's where you got to do a little more thinking because now we have a letter involved. All right, so you're going to have to remember what the letters correspond to as their numbers. So if we look back at our sheet here, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So we got to remember those numbers with those letters. So B is 11. So when we convert this, we got to do 11. So we got to do 8, 9, 10, 11. So 1, 0, 1, 1 for B. And then the next one is 5. So that'll be 4 and 1 is 5. So I put that all together. So that's 0, 1, 0, 1, 1, 0, 1, 1. And that's my answer. So the next one I have C, 3E. So again, I have to remember what those numbers are. So E is 14. So I've got 8 and 4 is 12, and 2 more is 14. So 1, 1, 1, 0 is 14, which is E. Then 3, that's 0, 0, 1, 1. 2 and 1 is 3. And C is worth 12. So that's going to be 8 and 4 give me 12. So again, I put all those 3 groups together. 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 0 for my answer. All right, and then one more here. So I have 150 in hexadecimal. So 0 is just going to be 4 zeros. 5, 4 and 1 is 5, and 1 in the ones place for the 1. Put all that together, so I have 0, 0, 0, 1, 0, 1, 0, 1, and 4 zeros. Okay, so again, each place value in hexadecimal is worth a group of 4 in binary. So you just take each one and convert it out, and then again, the extra thinking you have to do here is with the letters, because you have to remember what numbers they correspond to. Alright, so now looking at doing the opposite, going from binary to hexadecimal. Again, groups of 4. So we're going to take the same approach like we did with octal. We're going to start at the right side, work our way to the left, and make out groups of 4. So I got 1, 2, 3, 4, and then I just have those 2 there. So I can throw an extra 2 zeros if I want to make it a group of 4. Alright, so I need the first 4 place values of my binary number line. So 1, 2, 4, 8. 1, 2, 4, 8. And as you start working with this, you kind of memorize it, so you may not even have to write these up here. So for this group of 4, I just have a 1 in the 2's place, so that's a 2. And here I have a 1 in the 2's place, so that's a 2. So my answer is 22. Okay, easy as that. Alright, so again, making my groups of 4, so there's 4 and 4 there. So 1, 2, 4, 8. 1, 2, 4, 8. Alright, so here I have 8 and 4, and that is 12. So I don't write 12 here because it's got to be a single place value. So remember, everything that is 10 or higher is going to be a letter. So 12 is the letter C. Alright, and then this group, I just have a 1 in the 8's place, so that's worth 8. So the answer for that is 8C. Alright, again, groups of 4, 4, 4, and 4. So here I have a 1 in the 4's place. Here I have 4 and 2, which is 6. And here I have 8 and 2, which is 10, which will be the letter A. And then for the last one, group of 4, group of 4, group of 4. So I have 8, 9, 10, 11. So that's going to be B. I have 1 in the 2's place is 2. And then I have 8, 9, 10. So that's an A. Alright. So that's how we convert the binary number into a hexadecimal number. So again, just working your way right to left, divide it up into groups of 4. Use your 1, 2, 4, 8 and add up where the ones are. And remember, anything that is 10 or higher will be a letter, not a number. Okay? So hopefully that gives you good information to be able to count and convert with hexadecimal numbers. Again, go back through and look at the notes on Blackboard and let me know if you have any questions about hexadecimal, and we'll do more with the next number system that we're going to talk about. All right, thank you.